Hey, how's it going? This is Charlie Cuts here, and I'm here with another video of a project I've done. It's a little project called Hyperwire. It's a Max for Live MIDI sequencing device based off of it's called a cellular automation called Hyperwire. So let's see, we'll load up a little example here. Probably the easiest thing to show you first would be a little bit about Hyperwire itself. Hyperwire works, if you've ever heard of Conway's Game of Life, it's kind of a similar principle where you have basically just a grid of pixels, and you set up an initial condition for the pixels, and then you trigger through time generations, and you can watch as these cells move through different states. It's kind of heavy stuff. You can look up a little bit more about that on your own, but you'll see why it's important in a second here. And so what Hyperwire does is it allows you to edit, save, load all of your own little simulations, and then actually go in and assign MIDI events to them. If you look down here, got all the basic controls for load, save, reset. There's an editor built in to the screen over here, so you can draw stuff in, and you can click cells and then assign their MIDI event, and they'll turn a specific color. Now, I'm not going to bore you by making an example right now. We have all these nice ones saved, so let's find one that's going to be a little bit more easy to understand. So the basic premise, once again, is that you have these little sparks running around what are called wires in Hyperwire, and when a spark goes over one of the green cells, it triggers a MIDI event. And kind of the idea or purpose behind this project was to give people an interesting way that you could almost draw different step sequencers, arpeggiators, stuff like that. So for every project that you have open, there's 5 states the project can exist in, and this allows you to keep the same configuration of dots or MIDI triggers and set up different initial conditions, so that way you can do a different sequence of events. And so each state is triggered by the note velocity. So over here in Ableton, I have these clips with escalating velocities on the notes. And so we're going to start off with this audio pixel example. So I'm going to start playing this right here. And if you just take a look at what's going on, every time the clip restarts, it restarts this simulation, this wire world simulation, and then the spark, follows the simulation and then travels down the wire and activates the different notes. And so here I can demonstrate the different states by showing we have pretty much the same picture, the same MIDI triggers, and there's different ways that you can set that up to build little arpeggiators, sequencers, whatever really you can kind of imagine wanting to trigger notes in succession here. Let's see. So, pretty self-explanatory. That's kind of the technical details of the whole project. Why don't we just run and open a couple different interesting examples that I have over here, and you can listen and kind of get an idea of maybe how we want to use this to create a project, create some interesting effects. So here we have one set up to kind of play through this Baroque kind of chord progression real quick, and we can trigger another state and watch the same set of notes being played in a different way. Once again, your imagination is basically the limit on this kind of stuff. I thought it was a good idea to be able to give people a different way to sequence notes, try new things. This version itself is kind of just a prototype. Max for Live isn't particularly stable, and you'd actually see, if I had a lot going on the computer right now, it'll start to slow down the simulations. And I think at another point, it's important to mention that the generations triggered, and you can click this button down here. You can see I can make individual generations pass, that is all quantized to Ableton's internal clock. So basically, you are building what is ideally beat synced arpeggiators or whatever, but in reality, like I said, it's a little bit more of a prototype. Doesn't quite work that way. Let's see, we got another example over here. Let's start this one off. We might have to turn this synth up a couple octaves, it would sound like. Let's go over here. There we go. And then we can kind of see how it how the CPU load ends up affecting the arpeggiator. This is another one that was a fun one to make. Kind of supposed to look like the pipe from the Mario games, and actually what I've done here is built a couple of these little simulations that go forwards and backwards through the actual MIDI of the pipe sound effect in Mario. So. And actually, let's go and turn that up another octave or two, just so it really sounds like the actual. Alright. And once again, it's just kind of different examples of how you can kind of use this. And now let's move on to the second part, basically, the functionality. And so what I'm going to go do is, instead of having this trigger a MIDI synth, I'm going to have it trigger a drum rack. And keep in mind, I'll have to, when you're programming MIDI through the Hyperwire demo, you have to make sure that your notes are going to hit the right notes on the drum rack and everything like that. But I have a couple of examples right here of how you can use beats. And so this is another important part of the Hyperwire kind of world, is anywhere you have a loop like this and you have one of these sparks, which is a light block with a less light block behind it, traveling around, it'll move around that block with a period of generations that's equal to the number of pixels that block makes up. So what that lets us do is build these little clocks, as they call them. And you'll see in a second how we can use that to our advantage to do things like write beats. So you can see we got a kick drum. I think we got our snare, and then we have our hi-hat. And now you can see how in this example we've put multiple sparks on the clocks to show that now we have the snare triggering twice as fast as the kick drum, with the hi-hat 4 times as fast. Let's get another one here. These last two examples are actually the same to show that 4 sparks on one of these loops is the same as having 1 spark on a loop that's a fourth of the size. There's another one right there, and then my personal favorite. Got a little nice kind of break beat there. Alright, and then we're going to open the last beat demo over here. And same kind of deal, except now in this one we have loops are all the same size, and we're using sparks at different phases on the loop to create different beats. So let's go over here and trigger one of these. This one's got you got your 4 to the 4 kick, and you got your snares on the 2 and the 4, with some hi-hats and a little wood block. Nice little drum and bass beat there. Of course, a quintessential dubstep beat. And let's see if we have any more demos in here that we might find interesting. So I'm going to go ahead and switch it back to the instrument and load up. I think we have, oh yeah, this chord leaf one is a good one. Let's open that. And so this is another one, kind of a good example how you can get creative with it. It doesn't all have to be looping. This kind of is an interesting kind of arpeggiator or kind of a chord sweep or something like that. And I think that about does it. Maybe we have one more example here. Yeah, these chord circles. Not too interesting, but... And that pretty much does it. So thanks for watching my video. I hope you enjoy, and don't forget, if you have Ableton Live 9, you should be able to go onto my website. You can download the Hyperwire device. You can download all the examples. You can download this example project I'm using right here. You would be able to make your own, save them, load, everything like that, play around, and have some fun. So thanks a lot for watching.